So hello, welcome to our quarter one lunch and learn on geospatial Python. My name is Hilario Lumbreras. I'm a data engineer at Chevron. Um, Keith Fraley and I are both technical chairs for the PUG, and our goal this year is to present a lunch and learn session every quarter, and we hope to keep it on topics that are relevant to you and what you're doing at work. With that being said, we will continue on. So, what are we going to cover today? Well, we're going to cover our use case for using Python and GIS. I'm well aware that many people on the call probably use it every day at different capacities. And the purpose of this presentation is to get you thinking on maybe what are some other ways that we could use it and really focusing on different libraries that are advancing and how this could be potentially integrated into your workflows. We're going to be going over a series of technical notebooks in a Jupyter notebook format. So this is going to be available on a repo, and we'll share the link in just a bit. We're going to focus on a main scenario that is a fictional oil and gas base. And the idea of this scenario, along with the notebooks, is to use common language in a common mock trial, so to speak, that we can easily relate to, just so we can drive home the points. And at the end, we're going to really solicit feedback. We really want to curtail these sessions to you, and we want to make sure that we're presenting on what you're interested in. This is a very interactive, at least we want it to be an interactive presentation. So, while we're going through this, please feel free to put in the chat whether you agree, if there's other libraries that you're using, if you have other thoughts that you want to share. Please use the chat. We want this to be interactive, and we're hoping that you can also learn from other people in that chat because not one person knows it all. Without further ado, we'll keep on going. So in 2024, a geospatial professional must know fill in the blank. Please go ahead and put in the chat some of the technologies that a geospatial professional has to know, some of the key areas of topics. Maybe it's ArcGIS Pro, and just curious to see what people are putting in. So FME, thank you. Python, of course, Python. This is the session for you. Arcade. So we have other programming languages. GeoPandas, excellent. Node.js. All right, thank you for everybody who put something in the chat. So a geospatial professional must know quite a few topics, and this expands from applications such as ArcGIS Pro, Enterprise GIS, perhaps Blue Marble, fill in the blank. There's countless QGIS. It just depends on your use case, right? Also cloud. I think we are living in an environment where we have on-premise and cloud. So having some knowledge of Amazon Web Services, of Microsoft Azure, of Google is necessary. And I think it's safe to say that everybody is filling different personas, whether that's data architect, software engineer, or data analyst. And just as it was alluded to in the chat, that Python is ubiquitous in interacting and adding and extending and exposing all of, connecting everything together. So Python skills, people are probably using this, and we already said this. In FME, you're probably adding Python. You're using it to transform data. You're using it to automate your processes. You are perhaps using it for field application development, web development, data science solutions, whether that's R or Python. And that's for just some of the instances that Python is that you're using it. And as far as administration, maybe that's the Python for our Python API for ArcGIS, and you're using it for administration purposes. So we're already using it and all these buckets plus many, many more. And if there's any that we missed, please put it in the chat. I would love to hear it and see what your perspectives are on that. But and as we know, Python is open source. It's continually growing. It seems that as soon as you understand and you're good with one thing, there's new functionality, something changes in it, or maybe there's a new library that is of interest of you. And that's what we're going to cover today. We're going to be focusing on open source geospatial libraries. Some you may have heard of, and hopefully some of these will be new to you and something you can add into your toolbox. So we're going to be focusing on spatial analysis libraries, PySal, GeoPandas, SciPy. Perhaps you've seen them before. Maybe you have kind of a nod to it, like, oh, I'll get to that eventually. And hopefully these notebooks will be a good way for you to take that next step in understanding and application. Spatial indexing. Perhaps you've heard of H3, a very hot topic lately. Maybe you're wondering why this is important. We're going to discuss that. Perhaps you've used PostGIS, and maybe you've learned S2, which we'll dive into. And visualization. And this is an area where we're just scratching, and all these we're just scratching the surfaces. But we have so many tools at our disposal for visualization. And hopefully we'll just get to a few and hopefully show one or two that you didn't know before. Keith, if you could please post in the chat, all the notebooks that we are going to be discussing are in a repo. Eventually, we'll move this to a PUG repo, but in the meantime, I'll be in my personal repo. If you've never used it before, no problem. You simply go on to click the link and it'll show you to a page. There's a README file where you can see just a general synopsis of everything. And when you click into the individual notebooks, they are Jupyter notebooks. You already see a little bit of the graphics on there. And we're going to be going through these. So I'll be going from my personal Python IDE. But if you want to follow along, if you just want to grab it, this is kind of free for all to use, and all feedback will be welcome. So if you have any problems with that, just put it in the chat. Okay, so let's dive into it. So our scenario of oil leases and wells in West Texas. We're going to be using a mock scenario. This is just fictional, just for education purposes. And it's hopefully going to be something that's very easily related to. The way that the notebooks are structured is that they cover different topics. And then the final notebook, notebook number 5, covers everything all included. So we're going to be really focusing on that notebook number 5, and it's going to be following this use case. And we're going to be just glancing at the other notebooks just so you're aware of what's in them. And when you have time, you can just reference those or go through them on your own. So we have, in this scenario, two data sets. The first one will be a points for wells, and the second will be a polygon, so representing different leases. And we're going to be focusing on simple geoprocessing to complex. We're going to be looking at spatial indexing and spatial analysis. Okay, so for our first step in this mock scenario is data inspection. What are we looking at? What is, let's put some visual to this data that we've just received. And this can come in many formats. And we're going to dive into the first notebook in just a minute, but this is just showing, okay, yep, in Python, I can do simple visualization. Perhaps you knew that, perhaps you didn't. It can be something like a static map, as you see on the screen, or something that's interactive, where you can actually play with it. And so at this point in time, I'm actually going to dive into my notebook. So I am in Visual Studio Code. It's just a Python IDE. There are many out there, perhaps using Jupyter Notebook. So if you could just put in the chat, can everybody see my Visual Studio Code? Perfect. Thank you for that. Okay, so this goes into, in this notebook, it dives in a little bit more into providing more context just to make it a little bit more interesting. But we're going to go ahead and jump to the code since I already gave the context. So we're going to be creating artificial data. This is just a Python script that creates latitudes and longitudes and populates random production rates. And we are visualizing it just in a simple geodata frame. So important things to note here is that we're using GeoPandas, we're using Matplotlib, and these are geospatial libraries that we will get to more in just a minute, but just so you have an in context of what we're looking at. For our lease data, we also create synthetic data. This script is just taking a bounding box and filling it with many different squares. And I just want to make a note to how easy this is to do. And with Python, just with these a few lines of code, we are creating synthetic data to the parameters that we want. And this can be very valuable in user testing and making sure that perhaps your workflow is running well. And if it isn't a way that you have used Python, perhaps that's a different way that you could. So, it's not always, a map isn't always the best way to visualize our data. Sometimes we just need to see it, as a data frame, seeing what all our different points are. At this point, we are using Folium in order to make an interactive map. And you can already recognize some of the language where we're interacting with the geometry. You can recognize keywords like centroid. We're using the middle of this point. And we have a interactive map. So of course, this is, as with everything with Python, it's very customizable. Changing the symbology as to how you want it. And at this point in time, I'm going to just jump over to the geospatial notebook number 1 and just hit a few highlights about what's being represented in here. So the beginning is just talking about why use Python, which we've already covered. It highlights a few of the libraries that we just talked about: GeoPandas, Fiona, PyProj. Maybe you've used these before, maybe you haven't. What I'd like to highlight is just how, if you've never used GeoPandas before, you're bringing the power of pandas, the power of working with tabular data and marrying that with geospatial data in a really powerful way that can help with your processes. For PyProj, if you were thinking that, oh, geospatial data is special because I have projections, well, PyProj is a way that you can interact with that using Python. And there, just as with everything else, there's pros and cons to each library and different use cases that you would want to use them. And in this notebook, I have a few more examples of bringing in data in different formats. We're very familiar with shape files, but perhaps that we're bringing in with other types of geospatial data and providing simple visualizations, changing the projections. And for those who are maybe not too familiar with GeoPandas, providing a little bit more about the differences between Shapely and working with Shapely geometries. I'm also going to put a nod towards the second notebook that we have. And in here, it's breaking down the different geometries that we commonly see, with geospatial Python, well-known text, well-known binary, and talking about when to use one over the other, as there are different advantages and disadvantages. As well-known text is human very readable, whereas well-known binary is more compact. How do we manage that? And what are the benefits of GeoJSON as opposed to KML? Again, all these terms that we're probably very, very familiar with, and maybe we're not aware that it is used with geospatial Python. I also wanted to make a note on GeoParquet file format. And maybe this is something that you have interacted with, maybe this is something that you haven't, but it is my favorite way to store data, as it keeps it very, very small. And in this example, I have a very short demonstration of just using GeoParquet file format in order to store geospatial data and running a query on it. And funny enough, I'm comparing this to a CSV, and with the small amount of data that we have, the CSV is actually faster. And what I'd like to highlight from there is that, just as we commonly see, and that one tool isn't always the best tool for all, and that in many cases, what may work for one won't work for another. All right, I'm going to jump back to our presentation. Okay, so we talked about data inspection, we talked about data formats, and again, the big idea to drive home here is, whatever the geospatial data type you're working with, it can probably be ingested with Python, and we can work with it and we can create static and interactive maps with it. So next question is, okay, we have our data. Now let's do something with it. So, simple to complex geoprocessing. And in this visual, what we're going to make is total production per lease. This is a useful, this is useful for our use case just because, okay, now we have these points, now we have these polygons, let's marry these together. Let's do a join on this. Let's aggregate. And we can also create other visuals that provide other people with context. So for our lease data, we created synthetic owners, companies A through D. And if we just want an interesting way to view this, in order to, depending on our persona, this could be useful. And, perhaps this is something that can be included with our other sorts of geospatial products. For example, incorporating it into your story map that you have, where you have other sorts of layers that you're working with, and this is complementing it in a way that is perhaps easier than other applications. So in a similar way, we will jump back to our notebook. Want to showcase a few other interactive maps that you can create. And we'll come back to this visual in just a moment. Okay. So, with less than 20 lines of Python code, we are able to conduct a join and visualize it. So this is, again, just the power of matplotlib and GeoPandas and being able to produce a visual that is easy to share. And this is something that, if you're viewing it in GitHub or maybe you've downloaded into your own computer, you don't need any extra software in order to see these visuals. And that's one of the pros to Python. This also lends itself, depending on who their persona that you're working with, perhaps they don't use our common geospatial applications, but they use Jupyter Notebook. And so this is a way to communicate with them and to comment in code, comment in Markdown, and be able to share that. And if that isn't something that you're doing, it's perhaps something that you could add to your repertoire. I am going to go back to one of my favorite ways to visualize data in Python, and that's using the Kepler GL library. And what I really love about this is that it is, I love how it's used to ArcGIS Pro because that's where I learned GIS on, and I love how it's interactive and you can manipulate with it because sometimes you don't always know what you want. And so you can click into it very similar to other applications that we're familiar with. And we can, depending on the attributes that are present, change the polygons, change the shape colors, and all this is happening as in time. So for this example, we're going to do fill color based on these fake production rates. And as you can see very quickly, we can have a very powerful way to share our data. Downside to Kepler though is that it doesn't share as well, like for example in GitHub. But as far as if somebody's running it on their computer, then they'll be able to see it there. So complex geoprocessing. So in this example, which is just fictional, we're taking a look at a lease and the centroid of this lease. That's just this example. Perhaps with the lease, there are other geometries that you're more interested in, such as pre-existing wells. And maybe this is so you can do a horizontal drilling on already a well that's been started. So in this, in this lease, we have different oil wells. We have an interested point, and we're interested on, okay, what's the proximity of these? And we can conduct analysis just like that within our Jupyter, within our Python environment. So going back to our main scenario notebook, we're using Folium again to create an interactive map. Or let me go back a little bit. We're using SciPy in order to conduct these processes very quickly. We're finding the nearest well using the power of pandas in order to create our visual. And in this interactive map, we're also able to see different pop-ups. So just a nod to the amount of configuration that's present. I'm just going to pause here and see if there's any questions. If everybody is still with me, if you could just put a thumbs up or a happy face in the chat, that'd be great. Awesome. Okay, moving forward. So spatial indexing. So spatial indexing is something that really just depends on the use case. Maybe you've been exposed to this quite a bit. Maybe you haven't. But spatial indexing is a very powerful tool in our geospatial toolbox. And depending on your use case, there's one that's better than the other. And in this simple example, we're going to look at two. We're going to compare them. And this is just to show how not all spatial indexing is the same. And there are seemingly endless amounts of spatial indexes available through Python. In this example, we're looking at archery. Archery, just to put it simply, is like boxes within boxes. It is separating your spatial data and using the vertexes from other polygons in order to envelop others. And by doing this, you're able to organize your data, which may be advantageous depending on what your data is. Conversely, we have quadtree. And in quadtree, it is very hierarchical, where if you follow my mouse, we start with the square is subdivided, and then it's subdivided further. And depending on what our use case is, archery is better and quadtree may be better. And in our simple scenario, we're going to see that with our small amount of data, the archery query takes much, much less time than the quadtree. And while this is, Ilari, these are just seconds, this doesn't matter. But we know that there's not always just, 500 points. Sometimes there's 1,000,000 points. Sometimes there's more than that. And sometimes we need to see all of this and be able to query all these points. So in our scenario, I talk a little bit more about the spatial queries, and we can get into this, time dependent, but just going into what we're doing in the script, I wanted to make sure that these notebooks were easy to understand, and also a nod that as I was doing this, I was also using generative AI to help me to understand and debug. So I think if you haven't used it, which I think everybody has, in order to kind of bridge that gap to something that may seem unattainable, that it's a tool that's out there. So this is a little bit more, but this a little bit more lines of code. And just to kind of focus on the big ideas, we're focusing on how it's the same data, different types of indexes, and we're getting different types of results as far as speed. For spatial indexing, I'm going to the third notebook that is available in the repo. And here we talk about other indexes. And one of note that's been getting a lot of attention lately is hexagons. And if you haven't kind of spent a moment looking at it or hearing about it, I just want to highlight that If you haven't used H3 indexes, it is extremely powerful because of how different a hexagon is to other shapes that are out there. And in comparison, you have other indexes such as S2, which is kind of like a unrolled cube that's on the world. And if you're looking for something that, if your points, depending on where they are, that might be a better way to index it. But with the hexagon, everything is equidistant because of the shape of it. And if you haven't really looked into it, if you haven't thought into it, it's something that I've seen here at workflows at work. It's extremely powerful. There's a lot of libraries that we use to do this. There's H3 pandas that's available. There's the H3 library, and just a nod. And this notebook goes into a little bit about it and using it. But it is a powerful tool that's out there, and hexagon is the bestagon. All right. So we just covered spatial indexes. Now getting into spatial analysis. So uh, if you're like me, this is one of my favorite parts of GIS and of geospatial data, and really getting to that next level. For here, what I really want to focus on is less so on the actual statistics. So that's not something that I really want to highlight on, but it is more, we're very used to showing, our maps. At least in my experience, I'm very used to showing my maps and kind of saying, okay, like here's my analysis, but I'm not always the best at showing as to how I got there or why. And I think one of the really powerful tools with using geospatial libraries such as PySal is the opportunity to just very seamlessly integrate, the statistics and really hard analysis into our visual. And again, this is something that complements the geospatial products that we already have. And just in one point that I just want to keep on reiterating is how accessible this all is, and how this is growing, and how it's becoming easier and easier to use. And we'll take a look at that within our notebook. So more specifically, we're going to be focusing on spatial autocorrelation. We're also going to be looking a little bit at clusters. And again, just, I if I were to see something like our chart, and I'm like, oh my gosh, that's so much code to produce. And these libraries really make it accessible. Uh, One thing to note about the PySal library specifically is that there's different parts to it. And if you haven't got a chance to explore that, there's a lot of great documentation that's out there. And it can, yeah, and I hope these notebooks supplement that. And so what are we doing here? We're looking at, which spatial relationships matter. We're trying to look at our production data, going back to the scenario, we're looking at the production data and saying, okay, like we have all these data points, but which ones actually matter? How can we filter out through all that noise? And that's what these tools are helping us to do. We're looking at the result. We're looking at which clusters actually matter. And just to note, if you're following along in your notebook, this is again synthetic data, so yours will not look like mine, but I think that makes it much more fun. And here we are using the products from our previous cells, and we are focusing specifically on the significant clusters. So what are the ones that we want to look at? The ones with very low production, as well as the ones with very high production. And then very seamlessly, in the next cell, we can create a visual saying, hey, pay attention to here. This is what we notice the highest amount of production, according to our analysis. And this is something that, again, complements all of our other tools that we have available to us. And continuing with our same pattern, for our fourth notebook, we dive into PySal. We dive into the different parts of PySal that exist. And again, just hoping to break down that barrier of entry where you might be thinking, at least where I was thinking, oh, this is statistics. I'm not a statistician. This is a little bit too much for me. it isn't. And that barrier of entry really doesn't have to be that much. And in just a few lines of code, we can go ahead and iterate and experiment to, explore our data in different ways that maybe we didn't think was accessible before. Okay. So that concludes going through the notebooks, kind of going through the scenario. I hope it was useful. We do have time, so if there are technical questions or specific questions, happy to dive into that. Um, just want to share this slide that this is our core Q1 Lunch and Learn. We aim to have a different lunch and learn for every quarter, and we are interested in hearing what you have. So Keith is going to post a Microsoft form in the chat in order to gather feedback. We're very interested to hear what you have to say. We're interested to hear, was this helpful? Did we go into the level of detail that you're looking for? Were we using examples that were relevant? And if we're not, we want to know, we want to curtail this to you. Some of the things that we didn't touch on, talking about Python is we focused a lot here on vector data, but we didn't even really touch raster. And that's a whole other thing that, possibly we can do. I also think depending if the interest is there, we could also do a whole lunch and learn on spatial indexes, as that can be, a whole world of its own. Or perhaps that, you're interested in other topics. Something that we aim to do in the fourth quarter is to have a session on Experience Builder. Let us know if that's what you want to know or if that's not what you want to know. And just that we are very, very receptive to any feedback that you may have. At this point, that is everything that I have prepared. Very happy to go into any of the notebooks that you have, and go into any questions. I know that we touched on a lot of the big picture items, but really wanted to make sure that this data was accessible. There's a lot of comments in there to help you walk through it. And if you have any questions, we are available. You can find me on LinkedIn. Yeah, feel free to ask questions. Feel free to play with the notebooks, and if you have feedback there.
Hilario, one of the questions is how best to use GitHub if you're not experienced with it. How to download the examples and so on.
I see. So I think I have it pulled up here. Okay, so what if you're very new to GitHub and you're not sure what to do? Great question. So here I've gone to the GitHub page. When I click on an individual notebook, I can see generally most of what's in there. What you're seeing is a lot of markdown language, but you can download this raw file. And if you haven't downloaded Jupyter Notebook, that could be difficult, but if you look into downloading Jupyter Notebook, it's a free, easy to install, and executable will run. Or if you have another IDE or such as Visual Studio Code, then it'll just populate. If you try to open up in text, you're going to see a lot of formatting that isn't super helpful. But you should just be able to download the file, or if you kind of want to just extract the code, you have this other button, and you can specifically focus on the just capture the Python code that's available. I hope that's helpful. It's using GitHub is actually an art. I found there are if you want to interact with it programmatically and work with it in a way where you're making branches, there's a lot of YouTube videos that are out there, but I think generally what works for most people is working in a with an online format and just taking what you need from it, copy and pasting, and then putting that into your IDE, which if you're more comfortable with ArcGIS Pro, you can open a Python notebook in there, and they have that notebook capability in order to run your Python snippets in there. It also comes downloaded with ArcGIS Pro if you have that downloaded.
You have one more question that's just come in.
Yes, go ahead.
Recommendations for learning resources for someone who's just getting started with Python.
if you're just getting started, I personally love Code Academy. I think that's a great way to get introduced to it. Of course, there are other resources such as Udemy. There's other resources that are out there. I really enjoy it. And then after that, it's just having fun with it and trying to do little personal projects on your own. And I follow Medium, which is a platform where people put their different projects on. And there's a great geospatial articles on there where people are using uh, geospatial in ways that you might not imagine and incorporating it with machine learning workflows. And if you're interested in that, I think Medium's a great place for that. Yeah, I think great. But there's so many resources out there.
You have another question here. Are all of these geo packages available to install via other routes than pip, like Conda, etc.?
Yes. Yes. So if you're more familiar with Anaconda, there it's synonymous. Also, if you're working with other platforms like Ubuntu, it's also available there. And even if you're working with other languages besides Python. Any other questions?
I mean, I guess this is Keith, just kind of, thanking Ilario for the great presentation. I know it's a lot of work, and he's got a regular job as well. So thank you so much for putting that together. Yeah, obviously you can see for Q2 and Q3 that we have potential topics. So if there's any topics that you would be interested in hearing, kind of in depth or a deep dive into, feel free to reach out to myself or to Ilario to do that. If not, we'll be kind of presenting or coming up with 2 topics for Q2 and Q3 here shortly, and be on a lookout for those for sure.
Well, thank you for spending your lunchtime with us. Thank you for your time. Again, please fill out our Microsoft form. We're very eager to hear what feedback you may have. And until next time, thank you all very much.
Yep, thanks.